All right, so again, you can find this on Barron's educ.com website. You have to sign up, register for AP Computer Science Principles 2025, and then there's 3 practice exams. Test number 2. All right, in the below code segment, what can replace missing statements so that if a number in a list is divisible by 3 positive and less than 9, the program will display bingo. List is divisible by 3. So first, the value in the list is going to be item. Item's going to be every value in list. So that's, of course, what we're referring to. Divisible by 3 is using mod 3 equals 0. So really, this is our only answer choice right there. But positive and less than 9. So and greater than 0 and less than 9, yes. That would be our answer, okay? Pretty straightforward, pretty easy one to start. This is what we call a truth table. If you guys have probably seen this before, of true, true is false, true, false is true, false, true is false, false, false is false. So which combination would need to be true in order for this A and B to be true? So A has to be true and F has to be false. There's no other combination that creates true. So just look at it. A has to be true, B has to be false. So instead of B, you would put not B. So A is true and not B in order for the whole thing to be true. Does that make sense? Okay, the diagram below shows a circuit composed of logic gate. Each gate takes 2 inputs and produces a single output. What will the algorithm produce? All right, so I always kind of identify the ands because I know that both sides need to be true. All right, this has to be true and this has to be true in order for the or to be true. So true. So the fact that there's a true with an or means you can stop looking at it right away because the first one's always true. If it has to be warm or sunny to be a nice day and it's warm out, do I need to check if it's sunny? No, it's just one of them has to be true. So if this first one is true, you don't even have to check A. So true and true, and this is another or. So it's true or B. That means the answer will always be true. True when both A and B are true only? No. True when A is true? No. Always true regardless of values A and B. Does that make sense? Okay. So understanding how to short circuit, they call it short circuiting because you don't have to check the second value in an OR. When would you not have to check the second value with an AND? If both have to be true, can you just be like, I'm done after the first value? If it's false, because they both have to be true. So if the first one's false, it's false. The whole thing is false. If I have to be above 48 inches tall and above 13 years old to ride the roller coaster, if I'm too short, I can't ride the roller coaster. Okay? It doesn't matter how old I am. All right. What is the value displayed after the following algorithm is run? X is 7. Repeat until X is 4. So X is 6, 5, and then 4. It would stop. So display 4. There's no display inside the repeat until. So right away, that should tell you that you're not going to print multiple things. So that one's pretty straightforward. What is the value displayed after the following program segment is run? A is 3, A is 6, A is 6 plus 6, so A is 12. B is 12, B is 12 minus 12, so 0. So it would be 0, 12, 0. Is that an answer? Okay, that was a wild one. All right. which is intended to display the number of times a number target appears in a list. Count as 0. You're going to loop through every value. N is going to be each value in the list. If N is equal to target, we count. That is a problem. Bad. Very bad. You do not want an else with an if inside of a loop when you're counting. Because if you're resetting to 0 in the else, every time it's not the value, the target, N doesn't equal target, it's going to reset to 0. You could have 20 in a row that were equal to target. If the last one's not equal to target, it goes back to 0. That's not what we want. The program correctly displays count when the target is not in the list. Well, yeah, I guess it would display 0, so sure. Whoops. The program never correctly displays the correct value. No, we just said it does. Program correctly displays the count if the target appears once within the list and at the end of the list. Yeah, so if it's the last value in the list, it won't have an opportunity to hit the else because the else only happens when the if does not happen. So we get to the last value. Oh, it equals target. That's the only time it is in there. Count goes to 1. That's what we display. That would be the only time that it would work correctly. All right. Consider the following program. It is intended to display the index of the location where a target is located or to display -1 if the target is not in the list. Index is 0. Remember on the AP language, index starts at 1. I know. It makes me very upset. If AP College Board is listening, change that, okay? Index starts at 1, so that's why index plus 1 here. Before we actually go through the values, normally you see that at the end. This is actually a good thing because the first value, it shouldn't be 0, it should be 1, so that's a good thing. But they're using a for each loop, which, you know, is fine. So N is each value in list. If N equals target, found index equals index. Here's one of Barron's typos, lowercase I. I mean, I know it's not a big deal, but they're meaning this lowercase I. So that works. Again, the else. The else is -1. You find the target at the first value. It doesn't return found index or display it. If the second value is not the target, it would change it to -1. So that doesn't work. Which of the following test cases above would the above program display the correct index if the target number is 356? So only when it's the last value or it's not in the list. We just covered that on the last question. This is a very similar one. Instead of resetting to 0, if it's not in the list, it will be correct. Or if it's the last value, oh, found index, no, index doesn't go to -1. Found index is a different variable that is going to be set equal to index. So index still increases correctly along the way. Found index going to -1 is the bad thing. So yes, if it's not in the list at all, it will be -1, which is what we want. So 356 not in the list at all. -1, that's good. If it's the last value in the list, it will equal index, which increases the whole time. Index never goes to -1, just found index would. So yeah, that would be correct. All right. Lists 1 and 2 contain unique 8-number student IDs. An administrator at the school wants to create one list so that one list can be searched using binary search. The following abstractions are available to create the new searchable list: sort, combine, binary search. List 1 followed by elements of list 2. Sorts a list. All right, so if you sort the lists individually first, and then you combine them, that is no good. If I have a first hour class and I arrange those names alphabetically, and then a second hour class that I arrange that list alphabetically, and then I combine them, they are no longer alphabetical. I have one list and then another list. One list that's alphabetical and then a separate list that is alphabetical stacked on top of each other. No good. So you do not want to do that. Result list equals, well, that B doesn't do any sorting whatsoever. Binary search, it needs to be sorted. Combine and then sort, yay, that's good. Binary search, list and then value. Yeah, I don't see how it can't be C. Yeah. The algorithm below is used to determine if a number is a fizz, fuzz, or a fizz, fuzz. If a number is divisible by 3, display fizz. Usually it's fizz, buzz, but whatever. If a number is divisible by 5, display fuzz. What will the program segment display if the number 15 is used? Should display fizz, fuzz, right? Why wouldn't it be? Yeah. Okay. They didn't really give enough information on that. That was a weird one, but yeah. Which of the following program statements will return true if the variable num is a multiple of 11, or if it is one more than a multiple of 11? Ooh. Oh. Yeah, so if it's 11, it should be returned 0. If it was 12, is one more than 11, what would the mod return? 1. So it'll return true if it's divisible by 11 or has a remainder of 1 with 11. So yeah, I think that's the answer, yeah. I'm hoping we get to some word problems here. It doesn't feel like we've gotten a lot of coding problems in the beginning, which is fine, but here's a robot which is initially facing toward the top. Which of the following codes would move the robot 1 squared forward 1% of the time? So this is more of a random number. So random function is inclusive 1 to 100. So it randomly landing on 4 would be a 1 in 100 chance. That's fine. Boom. 0 to 100, it's inclusive, so that actually gives you 101 values, and that's not what we want. 1 to 100, less than 2, that only gives you one answer, and the less than or equal to 2 is pretty obviously not it. That would give you 2 answers. So, yeah, that is it. Which of the following code segments performs the following? Enters a number. Number is between 0 and 10 inclusive, write the word waffles. If the number is between 11 and 20, write the word Novak. I don't know where they're getting these words. If it is any other number, write the word Benji. 0 and 10 inclusive, waffles. Love the dog name Waffles. I feel like I need to name my next dog Waffles. All right. If number inclusive, so greater than 0 and less than 10 is not good. Greater than or equal to 0 and less than or equal to 10 is good. However, this they snuck this in here. What happens when it's 0? Well, num is greater than or equal to 0, so it would display waffles. Great. But it would not display Novak, but what would it display next? It would display Benji because this else and if are connected to each other. So it would display both waffles and Benji. They snuck that in there. So display waffles, else. This will automatically display Benji at the end because it's not even attached to an if or an else. They haven't really formatted this in a way that's very readable. D looks like our answer to me. Yeah. 0 to 10, 11 to 20, greater than 20, Benji. Now, someone gave me some stink about this because it says any other number, like it could be negative. Well, the other answers don't work, so this is the answer. So, just is what it is. What is the value displayed after the following algorithms run? X is 3, repeat 4 times, add 1 to X, so X would be 4, and then 5, 6, and then 7, 8, 9, 10, 11, 12. So display 12. So, oh, no, 4 times. So it would start at 3. 4 times it would add 1, 2, 3. So 3 plus 4 times 3, does that make sense? Is 15. If you get what I'm saying. All right. So it'd be 15. A computer can use 5 bits to store a non-negative number. Which of the following is the largest number that will not give an overflow error? Not give an overflow error. So everyone thinks C. That's the common answer, but that is wrong. Okay? If we are, this is how I'm going to do this. I am going to, oh, come on, snipping tool. Get over here. All right, so you have your 5 bits. The 1's place, the 2's place, the 4's, the 8's, the 16's. Now, it can store 32 values, but the lowest value is 0, 0, 0, 0, 0, and the greatest value is 1, 1, 1, 1, 1. So we can store 32 values 0 to 31. So it's tricky. 31 is our answer. However, it can store 32 values. Which is the largest number that will not give an overflow error? Would be 31. Painful little one. But that is something they will ask on the test. Absolutely. Okay, they'll try to trick you with one of those. Little sneaky. You need to know the difference between when they ask how many values versus what's the largest value. It's just a little difference there. Yeah. You'll have scratch paper. Programmer wrote a program uses a list of numbers called numList. Sum numList 1. Remember, numList 1 is the first value in the list for the AP language. Each val in numList. So sum is sum plus value. What is the issue with what they have set up? They start sum at the first value in the list, and then they add every value in the list. The issue is they add the first value twice, because sum starts at the first value, and then they also add every value, including the first value. Now, I don't know why they did that, and then it wasn't even used because the first value is 0, but, you know, whatever. I think this must be a 2-part question, I think, and they ask it on the next one. But 4652, which actually might even be a little bit trickier, is that they're going to ask it on the next one when they just showed you, oh, they act like, oh, it's easy, you just sum the list. And then they throw this at you, and you're like, wait, I needed to know the first part. So this would be 10, 21, 56, 62. As long as I did my math right. All right. Okay? They add the first value twice because they start sum at the first value. All right. We got another one. So they start sum at 0 this time. These cheeky guys here. 16, 46, 51, 57. 57. 5 less because you don't do they do it correctly this time. The program uses a list of numbers called numList. Find max numList. Max equals 0 for each value in numList. If value is greater than max, max equals value. So you're updating max, right? Every time value is greater than max. So max is going to equal the greatest value in the list because max updates to value every time value is greater than max. So that would be 35, right? All right, we will stop there. and go through the rest of this on Monday.